When gaining a deeper understanding as to how neurons communicate to each other in a functioning nervous system, we must first get to know the parts of a neuron as well as their function. To best show this, we will use an example of a motor neuron which has a function of communicating messages from association neurons in the central nervous system to the muscle fibers. Moving with the flow of the electricity through the neuron, let's start with the dendrites. These are small fibers that branch out from the cell's body, which houses the nucleus, receiving transmitted impulses from the presynaptic neuron.
The axon is a long wire-like process that the impulse travels down. The axon is surrounded by the myelin sheath, and the gap between each is called the node of Ranvier. When the impulse reaches the axon terminals, chemicals called neurotransmitters are released from the vesicles that hold them, but we will talk about this later.
The creation of an action potential involves the use of sodium channels, potassium channels, and sodium-potassium pumps, all of which are located in the axon of the neuron. The axon consists of both sodium and potassium ions at positive or negative charges. At rest, the cell interior is more negative than the cell exterior. When the axon is not generating a signal, it keeps a charge of negative 70 millivolts due to the greater presence of potassium ions, while the exterior is positively charged with the greater presence of sodium ions. The action potential activates when the charge of the inside and outside the axon are reversed, in which the axon becomes positively charged and the exterior becomes negatively charged. This process begins with the sodium channels opening up in the axon. This step is called depolarization. Once the axon reaches a positive charge, the sodium channels begin to close and the potassium channels open, causing potassium ions to enter the axon and balance out the positive charge. This step is called repolarization. To balance this out, the sodium-potassium pump begins to transfer sodium and potassium ions in and out of the cell so that the cell goes back to maintaining a charge of negative 70 millivolts. This step is called hyperpolarization. The shift in energy throughout this process is what generates an action potential.
Once the action potential occurs in the axon, traveling to the axon terminals and the synapse, the signal being carried to the neuron is transferred by chemicals called neurotransmitters. These neurotransmitters are held in the vesicles and transport to the synapse of one neuron to the receptors of the next neuron. These receptors are located in the dendrites of another neuron, which takes said message and repeats the process. Therefore, through the action potential process, the message is able to be passed on until the message reaches the central nervous system. To show this action, imagine all of a sudden touching a really hot pan that you were just using to make a delicious quesadilla. At that moment, the reaction potential is generated, passing on to neighboring neurons from the axon terminals of one to the dendrites of another, until it reaches the brain.
Think of when the dancer when she is running, like she is at resting potential. When she leaps, this relates to depolarization. When going down, think of that as repolarization. At the end of the leap, when the dancer bends her knees, think of that as hyperpolarization.
Just a quick recap, synaptic actions by second messengers can close channels that are open at resting potential. As well as this, neurons convey information using both electrical and chemical signals. When transmitting action potentials between neurons, information is being conveyed electrically due to the fact that an action potential is an electrical impulse caused by a sudden switching of charges between the inside and outside of the cell membrane. Chemical signals are used to communicate between the neurons as well, for the neurotransmitters are how the signal travels through the synapse between neurons.